A concrete block falls vertically from an airplane. The concrete block falls into the sea and sinks. Which graph shows the vertical motion of the concrete block? So we have speed with respect to time in all of these graphs. Let's look at this in terms of two motions. First, the falling from the airplane, then falling into the sea and sinking. So when it falls from the airplane, let's say the airplane's here and the block falls down like that, then it keeps falling and its speed increases because gravitational acceleration is 9.8 meters per second squared. So because of this acceleration downwards, the speed keeps increasing. But then at some point when it hits the sea, there it starts a sudden abrupt decrease in the speed as it hits the sea, and then it starts sinking at a much slower speed. So that means that the speed never actually changes to zero, but it keeps moving downwards a bit slower than before because water has a higher density than air had all this time. So that means we know that these two options are wrong because the speed has never come exactly down to zero. What about these two though? The only difference in these two graphs is the change in acceleration. Over here, the acceleration is increasing as time goes on, as the block falls. Over here, the acceleration is decreasing. The correct answer is where the acceleration is decreasing, because as the ball falls, the gravitational acceleration is 9.8 meters per second squared, right? But then this acceleration, which causes a force on the ball to move downwards, is counteracted by air resistance. And as the ball accelerates more, this air resistance keeps increasing and increasing. So over here, if the air resistance is zero, then over here it will be much higher. So this air resistance increases, which means the resultant force on the ball will decrease. And so if this resultant force downwards decreases, that means F equals ma, and mass is constant. If the force decreases, acceleration also decreases. So the acceleration decreases as time goes on. And that's why this kind of a curve is correct. And of course, this is the correct second part. So option C is our answer.